Number 5, tangent to the fifth power of x secant cubed of x dx. Again, we look at our two choices. We could let secant squared be 1 plus tan squared, or we can let tangent squared of x be secant squared of x minus 1. Taking a look at our first choice, if we were to use u equaling tan of x, du equaling secant squared of x dx, we need to have a secant squared of x at the back, with everything else being tans. So if we separate that out to get a secant squared at the back, borrowing two of them from the 3, we get tangent to the fifth power of x, which is fine. But then we have a lone secant x, and that cannot be changed into a tan. So that's out of the question. So u is equal to secant x, du is equal to secant tan. We borrow 1 from each to get tan to the fourth power of x, secant squared of x, and we have a secant x tan of x, and we can then use our trig identity. So again, we get the integral tan to the fourth power of x, secant squared of x, saving that secant tan at the back for our u substitution. So tan to the fourth power of x can be separated into tan squared, leaving all the rest of it alone, secant squared, secant tan. And we trade each one of those tan squareds into a secant squared of x minus 1. And this gets to be an algebraic nightmare here, but we FOIL it out, and we get secant to the fourth power of x minus 2 secant squared of x plus 1. You still have that secant squared, which you need to distribute backwards, and you get an integral of secant to the sixth power of x minus 2 secant to the fourth power of x plus secant squared of x. And again, we have that secant tan sitting at the back waiting for u to be secant of x. So now we need to distribute and make 3 different integrals. And we get the integral of secant to the sixth power of x, secant tan, minus 2 secant to the fourth power of x, secant tan, and squeezing in that last one, plus secant squared of x, secant tan. And now we're ready to let u equal secant of x. Du is secant of x tan of x, and we get 3 integrals, all power rules. Integral of u to the sixth du, minus 2u to the fourth du, plus u squared du, using the power rule, u to the seventh over seventh, minus 2u to the fifth over 5, plus u cubed over 3. Back subbing, we get secant to the 7th power of x over 7, minus 2 secant to the 5th power of x over 5, plus secant cubed of x over 3, plus c.